Hello there. Today's video is a bit different from the usual ones on this channel. It will run mostly at 1:1 speed, except for a few boring bits or obvious mistakes. Because yes, even bolts deserve some editing, and it's about modeling a bolt and a nut, including their aesthetic threads. So yes, this is a long video, and yes, it's intentional. While modeling, I'll share some thoughts about industry standards in CAD, and about the possible role Blender could play inside this landscape. This is not a tutorial, and it's not a comparison between software. It's more of a reflection, shared while working, slowly and on purpose. If this sounds interesting to you, let's begin. For years, people have been talking about industry standards, standard CAD software, standard workflows, standard pipelines. This is one of those moments where it's useful to pause and think about what's actually being described when we say standard. After working across different industries for quite some time, I'm not entirely convinced that this so-called industry standard has ever really existed. Every company has its tool of choice. Every sector swears by a different piece of software. And very often, even inside the same company, different departments use completely different tools, sometimes without even realizing it. This is another good moment to slow down a bit, because this detail matters more than it seems. So maybe the standard was never the software itself. Maybe the only real standard has always been the ability to exchange data and to work together despite using different tools. And this is where Blender becomes interesting. Not because Blender wants to replace CAD software, and not because Blender is secretly turning into a solid modeler, despite what my channel name might suggest. Here it's worth stopping for a second, because this misunderstanding comes up very often. Blender is interesting because it can act as a connector, a tool that lives somewhere in between disciplines, departments, and even different ways of thinking about geometry. Today, Blender is already widely accepted in mesh-based workflows. It coexists with tools like Maya or 3ds Max. Studios don't really ask which one is the standard anymore. They ask which one fits the task. This is another moment where it helps to pause briefly and look at how natural this sounds today. And the same question can be asked about CAD. What if the future is not about replacing Inventor, Keisha, or SolidWorks, but about integrating Blender into those pipelines in a way that actually makes sense? This is not a hypothetical question. It's something that is already happening, slowly, in small pieces across different pipelines. File exchange is usually where this discussion starts. Step IDIS, JLTF. This is a good place to slow down again, because file formats are often treated as a boring technical detail, while in reality they shape how people collaborate. These formats are often seen as a necessary evil, but in reality, they are the foundation of collaboration. They allow different departments to speak to each other. They allow design, engineering, visualization, and manufacturing to stay loosely coupled instead of being locked inside a single tool. This is exactly where developing dedicated tools and workflows starts to matter. Not to turn Blender into a CAD system, but to make Blender supportable inside industrial pipelines, even when solid modeling is involved. This is another point where it's useful to pause for a moment, because the difference between usable and supportable is subtle but crucial. Because once Blender becomes a supported node in the pipeline, something changes. It becomes easier to explore forms without breaking engineering constraints. It becomes easier to communicate ideas across departments. It becomes easier to iterate, visualize, explain, and test without constantly bouncing between incompatible environments. At this point, Blender stops being that extra software someone uses. It simply becomes part of the workflow. And this is usually where resistance slowly fades. There's also another aspect that often gets overlooked. Education. This is another moment where it's worth slowing down, because education is where long-term change actually starts. Today, Blender is already a trusted companion for students of 3D art, animation, and digital sculpting. It's accessible, it's powerful, and it's free. So the question is, why shouldn't the same be true for students of engineering, design, or technical and vocational disciplines? Not as a replacement for CAD education, but as a complement. A place where technical rigor and creative exploration can coexist early in the learning process. So maybe the real future of CAD is not a single piece of software. This is one of those ideas that sounds obvious only after you've said it out loud. Maybe it's a more flexible ecosystem, where tools are chosen for what they do best, and connected through shared data and shared intent. And maybe Blender's role in that future is not to become the standard, but to help redefine what standard actually means. With that in mind, enjoy the rest of the video. Before you leave, I'd really like to hear your opinion. This is another place where it's worth slowing down, because discussion is the most interesting part of this topic. Do you agree with these ideas, or do you disagree? Do you see Blender having a place inside CAD and engineering workflows, or do you think it should stay focused on mesh-based modeling only? There's no right or wrong answer here, and different perspectives are more than welcome. If you enjoyed this kind of content, consider subscribing to the channel and enabling notifications. It's a small action for you, but it makes a big difference for me. Thank you for watching, and see you in the next one.